All right, we're looking at 5.3, compare in order, compare in order integers. And that starts on page 363. All right, so in Fairbanks, Alaska, the average temperature for several months is shown on the thermometer. The average, oh my gosh. All right, so the average temperature for December is negative 6.5 degrees Fahrenheit, and the average temperature for March is 11 degrees Fahrenheit. So label December and March on the thermometer. Oh my goodness. Which months have a greater average temperature than February? And which months have a lower average temperature than November? Complete the inequality to compare the temperatures of November and February. So go ahead and complete 1 through 4. Pause the video now. All right, so for number 1, when I was putting in my averages, I kind of zoomed in here, and I saw that negative 6.5, this is our 0, this is our 10, obviously this is going to be our 5, so between 5 and 10, that's where I put my December. All right, then for March being 11, again, I zoomed in a little bit here, and I said, okay, well, if this is 0, this is 5, this is 10, it's just above the 10. Okay? So there I put my March and my December on there as well. For number 2, which months have a greater average temperature than February? So if February was my cutoff point, so right here, February is my cutoff point. The ones that are above that would be November and March. And then for my which months have the lower average temperature than November, November being my cutoff, now I've got February, December, and January. And then complete the inequality to compare the temperatures of November and February. November was 3 degrees and February was negative 4 degrees. November's average temperature was greater than February's. So I did the negative 4, fill in the gap. All right, so now let's go on. And it says compare integers. To compare integers, you can compare the signs as well as the magnitude or size of the numbers. Greater numbers are graphed farther to the right. So as the bigger the number goes, the farther to the right it goes. All right, so obviously if they're giving you a positive number and a negative number, the negative number is always smaller. It doesn't matter if this number 3 is bigger than this number 2. The fact is that 3 is a negative. So automatically, it's going to be the smaller number. Remember that the alligator eats the bigger number and poops out the little number. Okay? All right, so then the next one, we're going to be looking at not just the numbers anymore, because unfortunately when we're talking about 2 negatives, it gets a little confusing. When we're talking about positives, you'd know that 3 was bigger than 2. But in negative world, it's opposite world. So let's write this, opposite world. The bigger the negative number, the smaller it actually is. The more to the left, the smaller it actually is. So just keep in mind that if you can visualize a number line, that the one on the right is always the bigger number on the number line. All right, so fill in the circle, the blank, with greater than, less than, or equal to, less than, greater than, or equal to make the statement true. So 12 blank negative 4. Automatically, just looking at it, I've got a positive, I've got a negative. Positives always win. It doesn't matter what the number is. It could be negative 1 billion or trillion or gazillion, however many zeros I just put in here. And if it's negative, it is smaller, regardless. So we've got a greater than. So you're going to do A, B, and C on your own. A being the most challenging, I think, maybe B as well. But just think about that number line and where it is. The one that's furthest to the right is the bigger number. Keep that in mind. So go ahead and pause the video now and do A, B, and C. Okay, so we've got greater than, less than, and greater than. When we're looking at number or letter A, on the number line, our negative 3 is closer to 0 than the negative 5. Remember, opposite world, the bigger the number in negative world. If they're both negatives, the bigger the number, the smaller it actually is. So that's why I have the alligator eating the -3 and pooping out the -5. For B, we've got a negative number and we have 0. Well, although you think 0 is just nothing, nothing is better than being in the negative. So 0 is actually the greater number. So the alligator's eating the 0 and pooping out the -5. And then for C, that one really should be one of those ones that just goes duh for you, because you should look at it and say, I've got a positive and I've got a negative. Of course the positive is the bigger number. Duh. Okay? Please pay attention to that. All right, number 2. Justin has a score of -4 on the Trueville trivia game. Desiree's score is -5. Woo! Okay, does anybody watch Jeopardy? These are not good scores. Write an inequality to compare the scores and explain the meaning of the inequality. So -4 is actually greater than -5. So even though they both are really bad at this trivia game, Desiree is actually a little bit worse than Justin. So Justin is actually doing better. A -4 is better than a -5. Wow. Great job on the trivia game. For D, it says the temperature on Tuesday was 2 degrees Fahrenheit and the temperature on Wednesday was -2 degrees Fahrenheit. Write an inequality to compare the temperatures and explain the meaning of the inequality. All right. So the temperature on Tuesday is 2 degrees Fahrenheit. And Wednesday it's -2 degrees Fahrenheit. Obviously, we've got a positive number and we've got a negative number. It was greater on Tuesday than it was on Wednesday, because Tuesday was at least in the positives and Wednesday was below 0. All right, absolute value. Although -5 is the lesser value in example 2, it represents the greater point deficit. So Justin had -4, and what was her name? Desiree. Oh, poor Desiree. Desiree, we'll call her Des, had -5. Okay, the -5 meant she was more points in the negative. She was doing worse. She had a greater deficit, so she'd have to win back more points than Justin just to break even. And Justin was -4, which still not great, but apparently he's beating Des, our poor friend Des. All right, so ordering integers. You can use a number line to order a set of integers. Integers can be ordered from least to greatest or from greatest to least. So ordering the set of -9, 6, -3, and 0 from least to greatest on a number line, we'd be looking at the bigger negative numbers, the smaller they really are. So we've got our -9 over here, our -3, our 0, and our +6. The greatest number is over here, the smallest number is to the left. So to write this in order, -9, -3, 0, and 6. The other one is just to compare signs and then the values. So what they're saying is, how about we take all the negatives, we've got -9 and -3, then we've got our 0, and then we've got our +6, and put them in order. Which one's the smallest one out of the negatives? Well, -9 is less than -3, so that's the order it would go in. Then 0 would be next, and then 6 would be next because it's the positive. So same idea, okay? Just not using a number line. Just comparing the actual values. Thinking, here's my negative group, what order do they go in? Here's my positive group, what order did they go in? So since absolute value is always positive, it is not used to compare and order integers. Yeah, we don't want to find the absolute value of things because we're trying to put them in order from least to greatest. And you can't have -5 and +5 and take the absolute value of both and try and put it in order, because it's not going to work. This represents the same as this, and I can't put it in order by the actual numbers if I'm doing absolute values. All right, so E says order the set -4, 3, 11, -25 from least to greatest. They've given you a number line. And then you're doing the same thing with F with -18, 30, 12, -6, and 3. So go ahead and do those. Pause your video now and fill in the ones that you know. All right, so again, they gave you the number line on this one, so using method 1 is fine, but if you wanted to just think about grouping them according to comparing the signs and values, then I would say, okay, here's my negatives, my negative 25 and my negative 4. Which one's the least? This one, and then this is the order. And then I've got my 3 and my 11, going from least to greatest. It's going to go in this order, 3 and then 11, so that I can say, okay, so my numbers are negative 25, then negative 4, then 3, then 11, from least to greatest. Oh, no, it said greatest to least. Just kidding. So this one, I actually need to reverse it. I was just kidding about that one, guys. 11, then 3, then negative 4, then negative 25. Make sure that you read the directions. It says greatest to least. All right, so this time I'm going to go from the right and work my way to the left, since it's big numbers to small. All right, then F, I did correctly. Woohoo! This one, you can, again, group the negative numbers together and say, okay, I've got negative 18 and negative 6. And then my positives, I've got 3, 12, and 30. And I think it's pretty easy to put those in order. Understand that the negative's in opposite world. The bigger the number, the smaller it actually is. So negative 18, then negative 6, then 3, 12, and 30. And I feel like those are fairly easy. All right, the table shows the lowest elevation, for several continents. Order the elevations from least to greatest. First graph each integer, then write the integers as they appear on the number line from left to right. Again, if it's asking you to do a number line, great, but otherwise, let's look at the numbers. We've got 2-digit numbers right here. That's how I would probably go about it right now. And if I look at just that small number set, I know that 86 is my smallest number because it's an opposite world. Then negative 28 is my next, and negative 12 is my next. Then, looking at my 3-digit numbers, I know that 418 is my biggest negative, so that's the smallest really. And then negative 156 is my next, and then negative 105 is my next. So I hope that made sense, the way that I figured that out without using the number line, just based on the numbers. And I know that these seem overwhelming to have so many, numbers, but in reality, if you separate it by 2-digit and 3-digit numbers, it's a little bit more manageable. If you had all 2-digit numbers, you could break it up by 10s, 20s, 30s, 40s, 50s, whatever. Okay? Make it work for you. So that ends our lesson for 5.3 on compare and order integers. I hope you enjoyed the lesson. See you in school.